We're now going to look at chemical reactions. First off, the reactivity series. For the higher tier papers, you need to know the reactivity series of metals well, and remember the order the metals appear in. So, at the top of our list, we have the most reactive metals: potassium, sodium, calcium, magnesium, and aluminium. These metals, particularly the top three, are very reactive. As we go down the table, the middle group of metals are zinc, iron, tin, lead, and copper, which are less reactive. Right at the bottom of the reactivity table are silver and gold. These are very unreactive, which is why we use them for jewellery, cutlery, and fillings. Now, it's important to know the order of these metals that helps us to predict what will happen in chemical reactions. So, here are some tips on remembering the order of metals in the reactivity series.
When you're revising your chemistry, try to remember the order of the reactivity series. It'll help you when it comes to answering questions on the exam paper about displacement reactions, and there's always a question about it somewhere.
The way I remember the reactivity series is by a little rhyme. Pops stars can make absolute zillions if little children spend generously.
Once we know the order of reactions in chemistry, we can start to predict what is going to happen in a reaction. Let's look at another experiment. This time we take powdered copper oxide, which looks reddish-brown, and add the metal magnesium, which has been ground up into a powder. After mixing the two, we need some heat to get things going. But once started, the reaction is very dramatic. This type of reaction is called a displacement reaction. Displacement literally means taking the place of. Now, there's an important rule to help you. A more reactive metal will always displace a less reactive metal from its compound. So in this experiment, copper is lower than magnesium in the reactivity series, so magnesium is the more reactive metal. Here, the magnesium displaces the place of copper to become magnesium oxide, and we can write a word equation for the reaction. Magnesium and copper oxide makes magnesium oxide and copper. So another way of looking at a displacement reaction is using a diagram. So in this case, if we take iron and copper sulfate, the iron will push the copper out and it takes up the sulfate. We say the copper is displaced and will appear as a metal deposit. And we can write a word equation for the reaction. Copper sulfate and iron makes iron sulfate and the metal copper. In a displacement reaction, the more reactive metal will always displace a less reactive metal from its compound. We've set up an experiment with a solution of iron nitrate and added the metal copper to it. And in another test tube, we have taken silver nitrate and added copper to it. What do you predict will happen?
Okay, these are displacement reactions. Put the copper in. Okay, leave it in the iron nitrate. Right, let's see what happens. Yeah. So what do you think is going to happen?
So in the first part of this question, the reactants are iron nitrate and copper. Can you predict what will happen? Now part 2.
Okay, should we go on? Alright then. Right, pick the copper and some silver nitrate.
This time the reactants are silver nitrate and copper. What is going to happen? And write down a word equation. So, the answer to the first part.
I don't think there'll be any reaction because the
iron nitrate is higher in the reactivity series than the copper, so there won't be any displacement.
Absolutely right. There is no displacement reaction because the metal iron is higher in the reactivity series than copper. And the answer to the second part, silver nitrate and copper.
I think there'll definitely be some change. The colour's going already.
Oh yeah, yeah, it's because copper is higher in the reactivity series than silver, so it will displace. You can tell there's been a chemical reaction because there's a visible change, it's changing colour. Look, it's gone blue, that must be the copper nitrate.
Oh yeah.
The metal copper has displaced the silver, can now be seen deposited on the surface, and the blue colour is the copper nitrate. And your word equation would look like this. Silver nitrate plus copper makes silver plus copper nitrate. That brings us to the end of this unit on chemical reactions, and it's a good place to take a break. If you'd like to do more, there are more examples of displacement reactions in the book and on the website.